All right, so let's get started on this second hour of today's class. So we just took a look at one-tailed versus two-tailed hypothesis test and how to look up the cutoff scores for those, how to phrase your research and your null hypothesis in terms of that. So what we're going to do now is, all right, oh wait, here we go. All right, so what we're going to do now is we're going to reanalyze an experiment that we looked at previously, but this time do it correctly and see if that changes our conclusion. So once again, we're going to revisit the students at the elementary school where we as educational psychologists have been asked to take a look at their students, take a look at their scholastic program, and see if we can do anything to help increase the self-esteem of these students. And as previously mentioned, our intervention, our treatment consists of changing their push-up program, their kind of drills physical education program, with a new games program that we developed that's designed to reduce competition and increase self-esteem. So once again, let's read through this hypothesis test here. So it says a researcher is evaluating the effectiveness of a new physical education program, a games program, for elementary school children. The program is designed to reduce competition and increase individual self-esteem. A sample of 16 children is selected and the children are placed in the new program. After 3 months, each child is given a standardized self-esteem test. For the general population of elementary school children, the scores on the self-esteem test form a normal distribution with a mean of 40 and a standard deviation of 8. If the sample mean is 43.5, so remember in our original analysis with that sample mean, we found no difference, no treatment effect. But this time, if the sample mean is 43.5, is this enough to demonstrate a significant effect? Assume a two-tailed test with an alpha of 0.05. And notice that we did this originally as a two-tailed test, and we found no effect. But that's because we reduced the power of our own test by choosing the wrong test. So notice that the question itself is asking, does this increase self-esteem? So the question itself is saying, this is a program that is designed to increase self-esteem. So because of that, because we're only looking in one direction, it's a mistake for us to analyze this to see if there's an increase or a decrease. It's a mistake to do it as a two-tailed hypothesis. Because what we in effect did, and when we did it as a two-tailed hypothesis, is we took our alpha level, split it into two, and thereby reduced the power of our test. Because we literally took our alpha level, put half of it in the side that we were interested in, and the other half we just threw away. We threw away half of the power of our test because we were looking for a decrease. We don't care about a decrease. We don't want to crush self-esteem of these children. That's not what we were interested in. In order to do this test correctly, truthfully, we need to take our entire alpha level and put it in the side that we're interested in. So we take our entire alpha level, put it in the correct side, looking for an increase, and that increases the power of our test. That increases our ability to see or detect if the treatment actually did anything. So it's not cheating. It's not like we saw that there was an increase and then we said, oh, let's test for an increase. We were only ever looking for an increase. So it makes sense to put our entire alpha level on this side. It has to be decided before you take a look at the data. You cannot just take a look at your data and say, well, if it's in an increase, I'll do a one-tailed looking for an increase. And if it's a decrease, I'll do a one-tailed looking for a decrease. You're not allowed to do that. You need a very good reason to look one way or the other before you collect your data. We have that good reason because we are not looking for a decrease or an increase. We're not looking for a change, right? We're not looking for both. We're looking specifically for an increase. So it makes no sense to do a two-tailed. We should be doing a one-tailed test because, again, we're only interested in the increase. So let's see what happens now that we've maximized the power of our statistical hypothesis test to find the truth. what happens when we have that mean of 43.5? And remember, originally when we ran this as a two-tailed test with half the power, we didn't find an effect. We concluded that our games program does nothing. Now let's see what happens when we do it with the correct one-tailed test. All right, so still we're doing a one-tailed test this time, so this will be the first all the way through one-tailed test that we do, and still the same 5 steps. So the 5 steps has not changed, just slight changes in terms of step 1 and step 3. So step number 1, restate the question as a research hypothesis and a null hypothesis about the population. We want to know, is there an increase in the self-esteem for game students compared to the general USA population? For a one-tailed test, easiest to do your research hypothesis first. So we're going to do our research hypothesis, and we want to know, does the games increase? Do the games increase self-esteem? And we can write that out as the mean self-esteem for the games population is greater than the mean self-esteem for the general population. So for this one here, we have the mean self-esteem for the games population, the treated population, is greater than the general US students. That's your research hypothesis right there, covers the possibility of an increase. Your null hypothesis has to be the complete opposite of your research hypothesis. So your research hypothesis is that the games increase self-esteem. The null hypothesis is that the games do not increase self-esteem. So notice that the complete opposite of increase is not decrease. The complete opposite of increase is does not increase. So the null hypothesis becomes that the games program is less than or equal to the general USA population self-esteem. So that covers the less than, that covers the equal to, that covers all 3 possibilities. You know you've done your research and your null hypotheses correct when you have all 3 possibilities covered. Again, in some of your homework, I believe the equals is what they want for the null hypothesis. That's technically incorrect. This is the correct way to formulate those hypotheses. So just keep that heads up if you need to adjust it for your homework. All right, step number 1, done. Step 2, determine the characteristics of the comparison distribution. This is the only part you're missing right now. So we'll see how to do this in the next chapter. But right now, your comparison distribution still needs to be given to you. And it has a mean of 40 and a standard deviation of 2. So we have our comparison distribution. This is what we're comparing our sample to, not the population, but the comparison distribution, because the population is a distribution of individuals. The comparison distribution is a distribution of samples. We have data from a sample. We have to compare it to a distribution of samples. So this is your distribution of sample means. It's got a mean of 40. It's got a standard deviation. It's got a standard deviation of 2. This is where we need to find where our sample is on this distribution. So that's step 3. We got the characteristics of the comparison distribution. That's step 2. Step 3, we need to find a cutoff sample score. So for that, we are taking our comparison distribution and we are transforming it into a z-score distribution. And once again, we need to do that because this distribution is not in the back of your book. But the z-score distribution sure is. So we transform it into a z-score distribution with a mean of 0, standard deviation of 1. Make that look like a 0 instead of a 6. So a mean of 0 and a standard deviation of 1. Now we can find our cutoff scores. So we have an alpha level that was given to us in the question. We have an alpha level of 0.05. And we are putting all of that alpha level on the increase side. So this tail here, the only tail that we have, the increase tail, that is 5% of the distribution. So now we got to find out what z-score gives us 5% in the distribution, in the tail of the distribution in the tail. What score is that cutoff right there? So for that, we need to go to our distribution table. And again, I highly recommend, as you're getting familiar with this, draw this out so that you don't get confused. We're looking for 5% in the tail. This is the in the tail column. You scan, no 5%. This is the in the tail column. You scan, 5% right there, or the closest we can get to it. We take a look at what that z-score is. It is 1.64. We're looking for an increase, so it's positive 1.64. If we were looking for a decrease, if we were on this side, it would be negative. But we're looking for an increase. It's on this side, so it is positive. All right, so we have our cutoff score. Our z critical value is positive 1.64. Now we're ready to find out where our sample is on our comparison distribution. So our sample score, our sample mean is 43.5. So we know that it's somewhere in this positive side, right? 43.5, a sample mean of 43.5 is somewhere on this positive side because that's a mean of 40. So it's got to be somewhere on this side. But where exactly is it? Well, once again, we don't have this comparison distribution in the back of our book, but we do have this one. So we got to take this raw score, we got to change it into a z-score. So we can do that right here. We have a mean, our sample mean of 43.5. We have our comparison distribution mean. Whoops, where'd that 5 come from? We have our comparison distribution mean of 40, a mean of 40 and a standard deviation of 2. We pop that into our z-score formula and figure it out, and we get a z-score of 1.75. So that z-score of 1.75, that's a z-score of 0. That's a z-score of 1.64. 1.75 is somewhere past that cutoff score. It's somewhere in the tail, right? That's 0, that's 1, 1.5, 1.64. There's your 1.75 right there. And now finally we got to decide what do we do with the null and the research hypotheses now that we have that 1.75 z-score for our sample mean. And until you are absolutely blazing with this, make sure that you consult these two slides here. If the sample z-score is beyond the cutoff z-score, if it's crossed the line into the tails, yes it has, right? This is what this figure is telling us. It has crossed. What do? We accept the research hypothesis. We reject the null hypothesis. All right, make sure that until that is rock solid, you're consulting with these. Because on the other hand, if the sample z-score is within the cutoff z-score, if our sample mean stayed somewhere here in the body, if it didn't cross over into the tails, we would do the opposite. We would accept the null hypothesis and reject the research hypothesis. So as I mentioned before, we have a sample z-score of 1.75. We have that cutoff of 1.64. It has crossed into the tails. It has crossed that line in the sand. It is either a super, super, super weird sample or our treatment has an effect. And it's too weird for us to believe in its weirdness anymore. So we have to say, yes, our treatment has an effect. We reject the null hypothesis. We reject the idea that our treatment does nothing. We accept the research hypothesis, accept the idea that a treatment has an effect, and now we can conclude that the GAMES program increases self-esteem compared to the general USA population's physical education programs. So notice that now that we used a one-tailed test, now that we didn't throw away half of our alpha, half of our power, we ended up getting to the truth that our program actually does increase self-esteem, and we should generalize it to the population. We should let other people know about it. This is actually a program that does have an effect. It does increase self-esteem. All right, so what we're going to do right now is we're going to dedicate about half an hour right now to in-class practice. So we'll go all the way to 11 on this so we can get some in-class practice. you have a Excel sheet that has all the questions on it. So there it is right there. So you have an Excel sheet that has all the questions on it. It has the description of the situation. It's got all the data that you need. It will let you know how many tails to do it. So this, very importantly, is what half of your exam is going to look like. Your hypothesis testing is going to look like this for half of your exam. In your homework, you will need to determine occasionally, should I do a one-tail test or should I do a two-tail test? Look for language that indicates which one to do. So if they're asking for something like, does this drug cause a decrease in headaches? Did this intervention cause an increase in traffic accidents? Look for those words: increase, more of, more than before, decrease, less of, diminished, right? Look for those directional words. That indicates a one-tail test. If, on the other hand, they're just saying, is there an effect? Is there a change? Was there a difference? That's non-directional. That's either up or down, increase or decrease. So look for that language in the homework. Sometimes it's a little bit challenging to make that determination. So for the exam, I will let you know. For the exam, you take a look at that last sentence and it will say, do a one-tail test or do a two-tail test, right? It'll let you know. If it's a one-tail test, there will be language in the question that will let you know whether you're looking for an increase or a decrease. So for example, the second last sentence here, do the results indicate a higher estimate of speed for the smashed into groups? We're looking for higher estimates of speed. We're looking for an increase. We're doing a one-tail test looking for increases in the score. The other thing you'll notice in that sentence is that you have your alpha level. Make sure you find your alpha level because that determines the size of your tails. Once you get all your information and once you're ready to go, what you will do to answer these questions is you will basically fill in the correct values for every single step of the hypothesis test. So for the null hypothesis, should your null hypothesis be less than or equal to, or equals, or greater than or equal to, you will delete whatever you don't want in that cell. So you will basically double click on this cell and then you will delete whatever it is that you don't want. So in this case, you would delete that so that you have the correctly phrased null hypothesis. Same thing for the research hypothesis. You will delete whatever it is that you do not want so that what remains is your research hypothesis. For your Z critical, you will look up your cutoff scores based on whether it's a one-tailed or a two-tailed and your alpha level. For your sample, you will calculate the Z score for your sample mean based on your comparison distribution. And then finally, you will either accept or reject the null hypothesis and accept or reject the research hypothesis. And importantly, for full marks on step number 5, they need to be different. So you will always accept one and reject the other, and you're not allowed in the real world to hedge your bets and just say, I'll accept them both. I know one of them's got to be correct. So you need to have 2 different answers there to get full points. And then the last thing that I'll mention is that for this practice portion, I did put in the comparison distribution here for you, kind of highlighted and big and separate from the question. In the actual exam, that comparison distribution will be in the question itself. So it will say the comparison distribution has a mean of 34 and a standard deviation of 2.59, but it won't be out and bold and big like that for the exam. So just bear that in mind when you're working on your exam. So we got 2 kind of practice questions here. So I highly recommend give those a shot. Make sure that you know everything that, in terms of how to do those, in terms of how to put in your questions, what to look for. And just in case you need some extra sort of help on that, I would say try to do it on your own when you're first attempting it. If you can't get it, I do have it in the PowerPoint file. So just as a brief aside, the original articles are available on Canvas if you're interested in these psychology questions. But also the complete hypothesis test is there as well. So if you go through your practice sheets and you just can't get it, you just don't understand what's going on, take a look at the notes. We do have the correct answers in the notes. And if it still is not making sense to you, call me over and we'll get to the bottom of it. But right now what I want to do is, I do want to dedicate half an hour for this, so we'll go until 11:10, and I highly recommend let's try that, practice this Excel sheet, give it a go, and then if there's any issues, call me over, we'll get to the bottom of it, and let's make sure that we're prepared for hypothesis testing for exam 2. Yep?
Did you say that the sentence at the end, use the one to go S with alpha equals whatever,
Mm-hmm.
will be on the exam?
Yes, that will be. Yep. So you will not need to decide whether to do a one-tailed or a two-tailed hypothesis test. That is in your homework, though. In your homework, you will see questions where it's like, is this the right one or is this the right one? Before the exam, you will be told, do a one-tailed or do a two-tailed. So you can see this one is a one-tailed, that one's a two-tailed. You will be given the alpha level. So just be on the lookout for that. You don't have to make that decision on your own. All right, so let's open up practice time right now, and we'll restart the final portion of today's class at 11:10. All right, so just a real quick little note to help you out on this. So if you are in the habit of usually clicking with the mouse when you are updating a cell in Excel, you'll notice that when you try to put in the equals for the null hypothesis, Excel is going to do something weird. It's just going to highlight the cell that you're clicking on because it thinks that you're trying to give it a formula. It thinks that you're trying to make this cell equal to some other cell. So the way to avoid that is when you put in equals, instead of clicking somewhere, just hit enter, and that will leave the equals function, the equal sign in the answer cell, and that will allow you to have that as your null hypothesis. All right, so don't use the mouse to click away when you put in the equal sign. Just hit enter, and that will update that cell correctly. And this is also probably a good time to mention that if during the exam you run into that problem, feel free to call me over. I can't tell you what to put in the cell, but if something is going on and you just tell me, I want an equals in that cell and it's not working, I will put an equals in there for you. I'll show you the little, hit enter trick. If you erase all your symbols and you can't get, for example, less than or equal to, you don't know where to find it, call me over. I'll put less than or equal to in there. I won't tell you that it should be less than or equal to. That's your responsibility for the exam. But don't worry if Excel stuff happens. Call me over. I'll be more than happy to find that symbol for you and get it in there. All right, so let's wrap up this look at Chapter 5. So we now are able to do 4 out of the 5 steps. So the null and the research hypothesis for a one and a two-tailed hypothesis test. You can then, we still are unable to determine the comparison distribution. That will be given to you. But then you can determine your cutoff scores, your critical scores by looking in the unit normal distribution table. You can then calculate your samples z-score based on the mean and the comparison distribution, and finally make that final decision, accept or reject the null hypothesis. So we're done with Chapter 5. So just a little bit of housekeeping before we continue on today. First off, we have an exam coming up on Wednesday, and remember that when an exam is coming, the due dates can get a little weird occasionally. So just bear that in mind. We have a homework assignment, number 8, that is the Chapter 5. That is due Tuesday by 12:15. So that's so that you can get your homework done, get your feedback in timely fashion so you can review it for your exam. And then also the post-test is for Chapter 5 is going to be due Tuesday, June 4th by midnight. So that's a typical normal due date for that. And then any pretest points that you might want to still earn by doing your mastery points, just bear in mind that those are also due the midnight before the exam occurs. So exam number 2 is on chapters 4 and 5. So if you haven't completed them yet, you can still get points towards your pretest by completing the study plan. Mastery points for chapter 4, you can do that until midnight tomorrow. And also for chapter 5 until midnight tomorrow, pick up those points for that pretest and get that extra practice in for your mastery points and for your exam. So that is now the end of what we're going to be doing for exam number 2. So right here is where everything that we covered for exam number 2 is done. Because of the summer schedule, we are now going to start up on chapter 6, but that will be tested on exam number 3. So once again, when you're reviewing for your exam, this is where it ends. This is the end of the analysis. So just bear that in mind when you're doing your reviews.